Hello friends, today we will discuss about evaluation of tablet. This is Dr. Deepak and this evaluation of tablet is very important topic for GPAT, for your knowledge, for working in industry or for any competitive examination. The qualitative evaluation and assessment of tablets, chemical, physical and bioavailability properties are important in the design of tablets and to monitor product quality. So a tablet must be chemically, physically very standard and it should contain or it should have properties which are predetermined to be called a good quality tablet. These properties are important since chemical breakdown or interactions between tablet components may alter the physical tablet properties and generally this may have an effect on bioavailability of the tablet system. The tablets are to be evaluated before dispensing to maintain stability and bioavailability throughout the tablet shelf life. So, what are various evaluation criteria for tablets? Tablets are evaluated for general appearance, mechanical strength of the tablets, content uniformity, weight variation, disintegration test, and dissolution test. Weight variation and content uniformity are slightly related to each other that we will discuss in later sections. So first we will discuss about general appearance. A general appearance of tablets, its visual identity and overall elegance is essential for consumer acceptance, control of lot to lot uniformity and general tablet to tablet uniformity and for monitoring trouble-free manufacturing. So in general appearance, tablet is evaluated for shape and size, thickness, identification markings on the tablet and various organoleptic properties. So first, size and shape of a tablet. The size and shape of a tablet is designed to allow rapid production and also enable good consumer acceptance. It also enables rapid identification of a particular tablet among other tablets available. So by just seeing the size and shape of a tablet, most of the times we can identify the tablet. So this property is very important. A compressed tablet's shape and dimensions are determined by tooling during the compressional process. Which type of die, which type of punch you are using, which machine you are using will determine the shape and size of the tablet. Tablet thickness. Tablet thickness is influenced by the amount of fill materials in the die cavity, die diameter and compaction force applied. These three parameters or factors, that is die cavity, die diameter and compression force, play an important role in determining tablet thickness. At a constant compression load, tablet thickness varies with changes in die fill, particle size and packaging of the particle mix being compressed and tablet weight. So if the compression force is kept constant, tablet thickness determined by die fill, particle size of the granules, packaging of the granules in the die cavity and tablet weight. At a constant die fill, thickness varies with variation in compression load. So if the die fill or amount of granules filled in the die is constant, the thickness depends on compression force. If the compression force is constant, the thickness of tablet depends on, as we already discussed, die fill, particle size, packaging of particle mix and tablet weight. Various methods used for tablet thickness are micrometer, digital readout calipers and sliding caliper scale methods. Next is unique markings. Most of the time, pharmaceutical companies manufacturing tablets often use some type of unique markings on the tablet in addition to color, to aid in the rapid identification of the products. So these unique markings are also used for as an identification mark on a tablet product by various companies. These markings utilize some form of embossing, engraving, or printing. The type of information marking placed on tablet usually includes the company name or a symbol or a product code such as that from National Drug Code NDC number or the product name or the product potency. So all these information, one of these information is generally presented on the unique markings and they must be clear, non interfering with the quality of tablet or the process that should be evaluated. Organoleptic properties, most important organoleptic property is color. So most of the time pharmaceutical tablets use color for rapid identification and consumer acceptance and to improve the appearance of the tablet overall. The color of a product must be uniform within a single tablet, from tablet to tablet and from lot to lot. So the most important criteria in color is that the color should always be uniform in a single tablet, in a single tablet batch, or in a different tablet batches throughout the production of this tablet is taking place in the industry. Non-uniformity distribution of color within tablet is known as mottling. Methods for detecting color uniformity are tri-stimulus colorimetric measurements, reflectance spectrophotometry, and microreflectance photometer measurements. Next is odor. It generally tablets are odorless, but sometimes the odor can be a identification mark or can be a diagnostic tool for determining quality of tablet. The odor provides an identification of the quality of tablets. The presence of an odor in batch of a tablet can be indicate of stability problem. So sometimes the drug present in the tablet degraded and it produces a typical smell. Example, characteristic odor of acetic acid in degrading aspirin tablets. So if aspirin tablet smells like acetic acid, it indicates that the aspirin in the tablet is degrading and this can be a indication of unstable product. The presence of an odor may be characteristic of a drug, example vitamins, or it can be a characteristics of added flavoring agents of the tablet, for example chewable tablet, mouth dissolving tablet and others. Taste. Tastes are generally very important for tablets used for the mouth cavity like chewable tablets and dispersible tablets. So companies utilize taste panels to judge the preference of different flavors and flavor levels in the development of a product and also their uniformity. Next important parameter in evaluation of tablets is mechanical strength of tablets. Tablets require a certain amount of strength or hardness and resistance to friability to withstand mechanical shocks of handling in manufacturing, packaging and shipping, and also during handling by the patient. Common tests for evaluating mechanical strength of tablets are hardness of a tablet and friability of the tablet. So first we will discuss about hardness of tablet. Hardness of a tablet may be defined as the compressional force required to break the tablet when such a force is applied diametrically. The tablet is required to possess sufficient hardness so as to prevent its chipping, abrasion, breakage encountered during handling, transport, storage or use. Oral tablets normally have hardness of 4 to 8 or maximum 10 kg. However, hypodermic, chewable, dispersible tablets are much softer, up to 3 kg, and some sustained release tablets are very hard, much hardness Example, above 10 to 20 kg. Measurement of tablet hardness. The apparatus used for testing hardness are the oldest method or empirical method, that is manual testing, Monsanto Hardness Tester or Stokes Hardness Tester, Strong-Cobb Hardness Tester, Pfizer Hardness Tester, Heberlein Hardness Tester, Schieuniger or Heberlein Hardness Tester. We will discuss all in detail in following section. First, manual testing. Manual testing is very old method and seldomly used nowadays. It is an unofficial method, but generally operators use this method at the start of process to understand the hardness of the tablet. In this method, thumb act as a fulcrum while the tablet is held between the second and third hand finger. When the pressure is applied on the tablet with the thumb, the tablet, which breaks with a sharp snap, is considered to possess sufficient hardness. Next is Monsanto Hardness Tester. It is most commonly used and most easily available hardness tester in all the industries and all the institutions. It consists of an anvil spindle attached to a compressible spring, adjustable scale, and a knurled knob. The tablet is placed between the spindle and the anvil. It is placed so that the force can be applied diametrically and not on the flat surface. The force has to be applied on the edges of the tablet. The hard knob turned until the tablet sufficiently fits into the space between the anvil. The scale is adjusted to 0. The pressure on the tablet is increased by further turning the curved knob until tablet breaks, and the reading from the scale is measured as the hardness of tablet. Strong-Cobb Hardness Tester. It comprises of air pump that can be manually operated, which provides the force required to check hardness. In this, the tablet is placed on the anvil and pressure is applied. This causes the plunger to exert the pressure onto the tablet, resulting in its breakage. The force required in breaking the tablet is read from the scale. Generally, Strong-Cobb Hardness Tester gives 1.6 times more reading than Monsanto Hardness Tester. Pfizer Hardness Tester. It is also one of the most commonly used hardness tester. It consists of a pair of pliers. The tablet is compressed between a holding anvil and piston. Piston is connected to a gauge or meter, simple language, which enables direct reading of the compressional force applied. The handle of the plier is pressed until the tablet fractures or breaks. This method is very inexpensive, simple, and rapid to use. Heberlein Hardness Tester. The tester consists of upper and lower anvil. The lower anvil, after the tablet has been placed, is so adjusted that contact is maintained between the tablet and upper test anvil. A force is applied by weight suspended vertically. This movement is produced by an electronic motor. It delivers pressure on the tablet at a slow and uniform rate. The force required to break the tablet from the pointer movement on the scale is in kilograms is measured and hardness of tablet is determined. Schieuniger or Heberlein Hardness Tester. This tester consists of a mobile anvil and a stationary anvil. The movement of the former or mobile anvil is generated by electric motor whose speed can be controlled manually and correctly. The procedure involves the control movement of the moving anvil compressing the tablet placed between the two anvils and the pressure is applied till the tablets break. The reading is taken from the scale and hardness is determined. Next is very important and most important test of mechanical strain, that is friability test. Friability, the condition of being friable testing, is a method which is employed to determine physical strength of tablet upon exposure to mechanical shock and attrition. In simple words, friability test finds whether tablets are able to withstand sufficient mechanical stress during their manufacturing, distribution, and handling by the customer. The friability test is carried out in friability test apparatus. It consists of a plastic drum shaped chamber attached to a horizontal axis. The drum has an inside diameter of 287 mm and depth of 38 mm. This drum can be rotated with a speed of 25 rpm. The drum is circular. Pre-weighed tablet sample is placed in the friabilizer, which is then operated for 100 revolutions or 4 minutes, and tablets are removed from the chamber, cleaned properly, and again reweighted. The tablets which are compressed conventionally, the acceptable friability limit value is 0.5 to 1%. Simply speaking, the friability should be less than 1% to pass the test. It is determined by formula initial weight minus final weight upon final weight into 100. The initial weight is the weight of tablet before conducting friability test. Final weight is the weight of the tablets after completion of friability test. Next important parameter or method is or test is weight variation. Weight variation test is carried out to ensure that each of the tablet contains the proper amount of drug. Is uniformity in weight indicates that the tablet has uniform content, uniform amount of drug, and uniform quality. Competitive composite sample method. In this method, a composite weight of 10 tablets is determined, which are taken randomly from the batch. These are weighed throughout the compression process, and this process is carried out till the compression process is going on with intermittent intervals, with some time intervals. The composite weight is divided by 10. It gives an average weight, but contains the usual problems of average values. So in this method, the composite method is generally not followed nowadays because the average value have some inherent disadvantages which are applicable to this test also. Therefore, individual weight tablets or individual weight of tablet method is generally carried out for weight variation. The USP weight variation test is run by weighing 20 tablets individually, calculating the average weight and comparing the individual tablet weight to the average. So first we have to take 20 tablets, we have to calculate their individual weight, then we have to take average from that individual weight and then compare with the standard values. The percentage of weight variation is calculated by using following formula. Percent weight variation is equal to individual weight minus average weight divided by average weight into 100. So this will give some values of which meaning can be explained by given standard values. So the acceptable values for weight variation are as per the table. So they are different for USP and they are different for Indian Pharmacopoeia or IP. So for USP, if the average weight of tablet is 130 mg or less, acceptable limits is plus minus 10%. If the tablet weight is 130 mg to 324 mg, the acceptable limit is 7.5% plus minus. And when the tablet weight is more than 324 mg, the acceptable limit is plus minus 5%. When it comes to Indian pharmacopoeia, the weight range changes. For 10% plus minus 10% deviation, the tablet weight should be 80 mg or less. For 7.5% weight variation acceptable limits, the tablet should be 80 mg to 250 mg. And when a tablet is more than 250 mg, the acceptable limit is plus minus 5%. If tablet pass the test, if no more than 2 tablets are out of 20 tablets are outside the percentage limit, and if no tablet is differs by more than 2 times the percentage limit. So when we have already tested the 20 tablets and taken their average, the tablet or the batch passes the test if no more than 2 tablets are out of 20 tablets are outside the percentage limit, and if no tablet differs by more than 2 times the percentage limit with respect to their weight classification. Next is content uniformity test. This test is also very important as it confirms quality of tablet. Generally, weight variation test is considered sufficient to indicate unit to unit and lot to lot uniform drug content. But in specific conditions or in following conditions, the weight variation test is not sufficient and content uniformity test is conducted. When the tablets containing drug substance less than 25 mg or less than 25% of total weight of dosage unit, uniformity of drug substance is demonstrated by content uniformity test. So, the simple rule is 25 plus minus 25, right? So, if the percentage is less than 25% of total tablet weight drug content, or drug amount of drug present in the tablet is less than 25 mg, we have to go for drug content uniformity test. Otherwise, weight variation test is sufficient. So this 25 number we have to always remember, 25 mg or 25%. Content uniformity test is carried out by randomly selecting 30 tablets. 10 of these tablets are acid individually. The tablets pass the test if 9 of the 10 tablets contain not less than 85% and not more than 115% of the labeled drug content, and the 10th tablet contains not less than 75% and not more than 125% of the labeled content of drug. If more than one tablet are outside the range of 85 and 115% of label claim, but not outside the range of 75 to 125% of label claim, we have to evaluate 20 additional tablets. The requirements are met. The test is passed if not more than 3 tablets out of the total 30 tablets are outside the range of 85 115% of label claim, and no unit is outside the range of 75 to 125 of the label claim. So this test is also very important. Next is disintegration test. Disintegration testing accurately measures under standard condition the ability of a sample to break or disintegrate into smaller particles. Unless and until a tablet breaks into smaller particles, its dissolution or its drug will not get solubilized in the solvent or in the body at faster rate, because lower the particle size, more will be the dissolution. So a tablet must get disintegrated into smaller particles to release drug properly. This test is typically performed on solid dosage form, all kind of solid dosage form like tablet and capsules. It provides critical safety data on drug bioavailability in the body without having to utilize in vivo methods. It is a critical quality control step as it establishes consistency and uniformity across all the batches. So, all these evaluation tests we have carried out should be uniform in all the tablets, all the lots, and all the batches that are taken for a product. The disintegration test apparatus and disintegration test is carried out in disintegration test apparatus. It consists of a basket as a rack assembly containing 6 glass tubes that are 3 inches long, open at the top and held against a 10 mesh screen at the bottom. So these 6 glass tubes of 3 inches are open at the top and are closed by a 10 mesh screen in the bottom. A tablet is placed in each tube and basket rack is positioned in 1 liter of water or whatever may be the disintegrating fluid as per the official test. A standard motor driven device is used to move the tablet assembly containing tablets up and down through a distance of 5 to 6 cm at a frequency of 28 to 32 cycles per minute. According to the standard, the tablet must disintegrate and all particles must pass through the 10 mesh screen in the time specified in the official books. If any residue contains, it must be a soft mass and not a hard mass. A reasonable disintegration time should be between 15 and 30 minutes, that is maximum limit, although the time will depend on the product. Uncoated tablets generally should disintegrate within 15 minutes. Film coated tablets should disintegrate within 30 minutes to pass the test. Disintegration test for specifically carried out for entry-coated tablets or delayed release tablets are as follow. A one tablet is placed in each of the 6 tubes of the basket and the apparatus is operated using stimulated gastric fluid of pH 1.2 maintained at 37 plus minus 2 degrees centigrade as disintegration fluid or immersion fluid. After 1 hour operation in stimulated gastric fluid, the basket is removed from the fluid. The tablets should show no evidence of disintegration, breaking, cracking or softening. Then the fluid is replaced by simulated intestinal fluid having a pH of 6.8 to 7.4 maintained at 37 plus minus 2 degrees centigrade, and the apparatus is operated for the time specified in the monograph. To pass the test, all the tablets should disintegrate completely in this basic pH or in simulated intestinal fluid. If 1 or 2 tablets fail to disintegrate completely, the test is repeated on 12 additional tablets. The tablets pass test if not fewer than 16 of the total of 18 tablets tested disintegrate completely in specified time. In vitro dissolution test. Dissolution is the process in which substance form solution. A dissolution test measures the extent and rate of solution formation of drug present in the dosage form. So in dissolution, simply speaking, we find out the capacity of a tablet to go into a solution. The bioavailability and therapeutic effectiveness of drug in the dosage form depends upon the dissolution rate of its dosage form. Dissolution rate is defined as the rate at which the drug is released into the systemic circulation from the dosage form. And we cannot calculate or evaluate this every time in the in vivo media. So we have to carry out in dissolution apparatus. This is also called as in vitro bioavailability test. Dissolution test is carried out in dissolution test apparatus. Some of the types are there are around 7 types. we have given 4 types: USP dissolution apparatus 1, rotating basket; USP dissolution apparatus 2, rotating paddle; USP dissolution apparatus 3, reciprocating cylinder; USP dissolution apparatus 4, flow through cell. In our future presentation, we will discuss dissolution test and dissolution apparatus in detail. The test is performed in 900 ml generally. This depends on the solubility of drug and the official method. Generally 900 ml dissolution fluid is taken and RPMs, the machine is rotated at RPM which are also reported by standard test at 37 plus minus 0.5 degree centigrade. Generally single container methods, dissolution test apparatus were available in old days. Nowadays 6 to 12 dissolution flask containing machines are available. So for carrying out the test, we have to place one tablet in each flask and then rotate the apparatus or start the test. In the dissolution fluid, specific amount of samples are to be withdrawn at predetermined time interval from the dissolution flask and replaced with the equal volume of the same dissolution medium. The samples are analyzed with suitable analytical method like UV spectrophotometry and HPLC for drug release. So, after taking 900 ml of dissolution fluid, we have to place one tablet in the dissolution fluid. We have to operate the apparatus at specified RPM at 37 plus minus 0.5 degree centigrade using dissolution fluid, which is also reported in standard books, and then we have to withdraw some sample and assay it using photometric method or instrumental method or titration simple to find out the drug released in the solution. The acceptance criteria for dissolution, this is also called as S1 S2 criteria. So one stage, that is S1, is considered to be passed when 6 tablets which are tested for dissolution test contains not less than Q plus 5% of drug in given specific time. So what is Q? Q is the amount of drug to be released at particular time, because we take the samples in particular time and then we analyze. So the calculation is such that at particular time how much quantity of drug is released in the dissolution fluid. So based on that, that is called as Q. So based on that, this test is accepted or rejected. So S1 is criteria when all of the 6 tested units release drug at more than 5% quantity which is specified at that particular time limit. If that is not acceptable or that is failed, then we have to go for S2. We have to test again 6 tablets. So total number of tablets is 12. So average of 12 units, that is S1 6 plus S2 6, is equal to or greater than Q, and no unit is less than Q minus 15. So out of 12 tablets, all the tablets average release is more than the quantity specified that during at that specific time interval, and not a single unit is less than Q minus 15. If this is also failed, we have to go for S3. Again we have to test 12 tablets. Total tablet tested are now 24. So the average of 24 tablets is equal to Q, equal or greater than Q, and not more than 2 units are less than Q minus 15, and not a single unit is less than Q minus 25. For example, if quantity drug released in 45 minutes is 85%, if quantity of drug released Q45 or Q for 45 minutes is 85% for S1, all 6 tablets should release 90% of drug. Then it will pass. If that is not possible, the 12 tablets for S2 criteria should release drug at least 85% or more, and not a single tablet should be less than 70%. If that is also not possible, we have to again go for S3, in which all 24 tablets should have drug release 85%, average drug release of 85% or more, and not more than 2 units are less than 70%, and not a single unit is less than 60% to pass the test. And one more point I will like to discuss is that what is official test and what is unofficial test. Official test is the test which is given in pharmacopoeias, and unofficial test is the test which is carried out generally for ensuring the quality of tablet, but it is not given in the pharmacopoeias. Thank you. If you like this video, if you like the content of video, please subscribe to Cobra's Academy for pharmaceutical presentations and pharmaceutical topics, which will be very useful for GPAT and other competitive examinations. Again, thank you.